Hey guys, let's look at some more examples of decomposing partial fractions. So the first thing we want to check is the denominator's power higher than the numerator's power. It is, so we don't have to worry about long division. The next thing we have to do is factor the denominator. So we have that x cubed minus 2x squared plus x minus 2. So the way we're going to factor this is by grouping that step and splitting the middle term. So we're going to look for the greatest common factor of the first two terms. That's going to be x squared. And when we factor out that, we're left with x minus 2. Then we're going to look at our greatest common factor of x minus 2, and that's 1. So we're left with x minus 2 in parentheses. So that factors down into x squared plus 1, x minus 2. Now let's check out this x squared plus 1. Can that be factored? Can we find two numbers that multiply to positive 1 and add to 0? No. So that is prime, or it's not factorable. So our denominator factors down into x squared plus 1 and x minus 2. We still have that 2x squared plus x plus 5 in our numerator. So now we need to determine our terms. So one of our denominators is going to be that x squared plus 1. That other denominator is going to be x minus 2. Now over here, this denominator is quadratic. Since he's quadratic, I need ax plus b up on top. X minus 2 is linear, so I just need to put a c on top of him. And I know that these need to add to be 2x squared plus x plus 5 over x squared plus 1, x minus 2. So what can be helpful at this point is sometimes to write those factors that you just came up with, so that way when you determine A, B, and C, it's easier to plug into because you're not having to dig through all your work from before. All right. So we know that if we want to add fractions together, we need to get a common denominator. So I need to multiply my first fraction by x minus 2 over x minus 2. And my second fraction by x squared plus 1 over x squared plus 1. Now make sure you put parentheses around that ax plus b. So that way you can distribute everything out, FOIL it if you did that when you were in Algebra 1. Ax plus x is ax squared. Ax times negative 2, negative 2ax. B times x is bx. B times negative 2 is negative 2b. Remember, since we have a common denominator now, we pretty much just ignore it. All right, let's go ahead and distribute c on out as well. We got a cx squared plus c times 1 is c. And we want that to be equal to 2x squared plus x plus 5. So now we're going to set up our equations. So let's make an equation out of our x squared stuff. We have an ax squared. We don't have a bx squared, so I'm just going to put a 0 there and just to remind me. We've got a cx squared, and that's going to be equal to 2x squared from the other side. Now we're going to make an equation out of our plain old x's. We have a negative 2ax We also have a bx. We don't have a cx, so we're going to put a 0 there. That will be equal to 1x over on the other side. Then we'll make an equation out of our plain old numbers. There's no term where x has a constant with it or doesn't have a variable. We have negative 2b and then we have plus c. And that will be equal to 5 over on the other side. So then we'll make an augmented matrix out of those equations that we just had. So for my x squared equation, the coefficient on ax squared is 1. Then we had 0. The coefficient on cx squared is 1. And that's equal to 2. My next equation for the x's, my coefficient on ax is negative 2. My coefficient on bx is 1. I have a 0 for c, and that's equal to 1x. Then I have my plain old numbers. I got 0. My coefficient on b is negative 2. My coefficient on c is 1, and that's equal to 5. So then we're going to put this guy into reduced row echelon form. So we're going to go to our calculator, click New Matrix. This is a 3 by 4 matrix. You've got 1, 0, 1, 2, negative 2, 1, 0, 1, 0, negative 2, 1, 5. We'll press enter. Then we'll click reduced row echelon form and choose the matrix that we just had. And right here is going to show us what A, B, and C are equal to. That first value on top in my first row, negative 1, that's what A is equal to. B is equal to the value in the middle, negative 1. And C is equal to the value at the end, positive 3. So now that we know what A, B, and C are equal to, we can pop those into our values from above. So we know A is equal to negative 1, so that's negative x. B is equal to negative 1, so that's minus 1. And that's going to be over x squared plus 1, plus, and then C was 3, and he'll be over x minus 2. And that's my partial fraction decomposition. Let's look at another one. So the first thing we have to check is the denominator's power higher than the numerators. And it is. The bottom power is to the 4th. The top is only squared. So we don't have to worry about long division. So everything's all factored for us. Now we just have to go through and figure out what our terms are. Now right here we have a repeated power with that x plus 3. So we're going to have x plus 3 in one denominator. And then we're going to have x plus 3 squared in the next denominator. Because remember, whenever we have a repeated power, we count up until that power. Now, since that x minus 3 part is linear, I'm going to have an a on top of that. Since that x minus 3 part is linear, I'm going to have a b on top of that. X squared plus 3. Are there two numbers that can multiply to positive 3 and add to 0? No, so that's prime. So that means that we can't factor it. So x squared plus 3 is what's going to be in our denominator there. Now, since x squared plus 3 is quadratic, I need to have cx plus d in my numerator. And we want that to be equal to x squared. And I'm going to put a 0x in there just because it helps me, plus 15. All right, x plus 3 squared times x squared plus 3. All right. So I'm just going to go ahead and rewrite all of this real quick. I'm going to have to take a times. Okay, so the next thing we need to do is get common denominators. So my first fraction has an x minus 3, but I need an x minus 3 squared. So how do I get a squared on there? I'm sorry, x plus 3. That should be a plus. So how do I get a squared on there? Well, squared means it's multiplied by itself, right? So that means I need to multiply by another x plus 3 over x plus 3 to get that to be squared. Then he needs an x squared plus 3 over x squared plus 3. My b fraction, all he needs is an x squared plus 3, so we'll put that on top and on the bottom. And that cx plus d fraction needs the x plus 3 squared piece over x plus 3 squared. So now that we have common denominators, we're just going to ignore the whole thing. Now this next line is important to stay very, very organized. So it's going to get a little bit messy, but we're going to try our best, okay? So I'm going to keep that a outside, but I'm going to multiply x plus 3 times x squared plus 3 together. So x squared times x is x cubed. X squared times 3 is 3x squared. Plus 3 times x is 3x, plus 3 times 3 is 9. Cool. B will be multiplied by x squared plus 3. I'm going to make sure to put cx plus d in parentheses. X plus 3 squared means I need to multiply it by itself. So we'll get x squared plus 6x plus 9 when we multiply those together. So now if you'd like to, you can distribute that a, b, and c out if that's helpful to you. I think it is. So we have ax cubed plus 3ax squared plus 3ax plus 9a plus bx squared plus 3b plus cx squared, x cubed plus 6cx squared plus 9cx plus dx squared plus 6dx plus 9d equals x squared plus 0x plus 15. Okay, so now we'll make an equation out of all of our x cubed stuff. So we have an ax cubed. We don't have a bx cubed, so we'll put a 0 in there. We have a cx cubed. And we don't have a dx cubed, so we'll put in a 0. And we don't have any x cubed terms over on the other side, so that needs to be equal to 0. Then we'll make an equation out of our x squareds. We have a 3ax squared. We have a 1bx squared. We have a 6cx squared. And we have a dx squared. And that's going to be equal to 1x squared over on the other side of the equation. Then we'll make an equation out of just our plain old x stuff. So we have our 3ax plus, we don't have a bx, so we'll put 0 plus. We have 9cx plus, and then we have a 6dx, and that will be equal to 0x on the other side. Then we'll make an equation out of our plain old numbers. We have a 9a plus a 3b plus no c, so we'll put a 0 plus. Then we've got a 9d, and that's going to be equal to 15 over on the other side. All right, so then we're going to make an augmented matrix out of this. So for my x cubed, my coefficient on a is 1, then we have a 0. My coefficient on c is 1, then we have a 0, and then that's equal to 0. In my x squared line, my coefficient on a is 3, my coefficient on b is 1, my coefficient on c is 6, my coefficient on d is 1, and my coefficient on x squared is 1. In my x equation, we got 3 on a, we have a coefficient of 0 for b, coefficient of 9 on c, coefficient of 6 on d, and that's going to be equal to 0 on the other side. And then for the last one, coefficient on a is 9, coefficient on b is 3, we don't have a c, so that's 0, coefficient on d is 9, and that will be equal to 15. So then we'll go back to Desmos, clear those guys out, new matrix. This is a 4 by 5. So we've got 1, 0, 1, 0, 0, 3, 1, 6, 1, 1, 3, 0, 9, 6, 0, 9, 3, 0, 9, 15. And then we'll press enter to keep that guy. Click reduce row echelon form and choose matrix A. And it could be helpful to put that as a fraction. So here from our reduced row echelon form, we have figured out that A, that first blank, is equal to 1/2. B, that second blank, is equal to 2. C, that third blank, is equal to -1/2. And D, our last blank, is equal to 1/2. So there's what we know so far. So let's take what we had before and pop in those 1/2s. So we'll put 1/2 in for A, so we'll have 1/2 over x plus 3 plus. B is equal to 2, so he'll just go over x plus 3 squared plus. C was negative 1/2 x plus, and then D was also 1/2 over that x squared plus 3. Okay, so here's what I would like for you to notice. In this last guy, we can factor out a 1/2 from there, right? Good deal. All right, so here's what we can do. Having a fraction in a fraction is pretty strange, right? So what we can do is we can write this as with our 2 down here in our denominator. So 1/2 over that stuff is the same thing as 1 over 2 times our denominator. That 2 over x plus 3 squared doesn't need to change. We factored a 1/2 out of that negative 1/2 x plus 1/2, and we can do the same thing, bring the 2 down to our denominator. So we still have our negative x plus 1 in the numerator, but now we have a 2 in front of our x squared plus 3. And that will be our answer. Let's try one more. Is our denominator's power higher than our numerator's power? No, it's not. So what we're going to have to do first is polynomial long division. So the stuff outside of the square root, in the denominator, x squared plus 3x plus 2, that's going to go outside the long division symbol. The stuff in the numerator, x cubed plus 3x squared plus 6x plus 7, goes underneath the long division symbol. Then we'll divide our first terms, x cubed divided by x squared, and we'll get x. Then we'll multiply. X times x squared is x cubed plus x times 3x is 3x squared plus x times 2 is 2x. Then we need to subtract, so we'll switch all of our signs. X cubed minus x cubed is 0. 3x squared minus x squared, 3x squared is 0. 6x minus 2x is 4x. And then we'll bring down the 7. Now we'll take 4x divided by x squared. Well, that's not really helpful to us. So this 4x plus 7, that is my remainder. So I have x plus 4x plus 7 goes in the numerator. In the denominator, we have that x squared plus 3x plus 2. All right, so now we're going to rewrite our problem as x plus 4x plus 7 over x squared plus 3x plus 2. Now, we're just going to decompose that 4x plus 7 over x squared plus 3x plus 2. But we still need to have our x in our answer because it's part of the decomposition. Okay, so first of all, I'm going to put x plus. We need to factor our denominator. What are two numbers that multiply to 2 and add to 3? 2 and 1. So that's going to be x plus 1, x plus 2. So that means I'm going to have a over x plus 1 plus b over x plus 2. But notice I still have that x plus, right? Once I find a and b, that will be my answer. Okay? So here in just a minute, we'll be able to find out, we'll have x plus, that will be our answer. We'll look at that in just a minute. Okay. All right, so let's look just at that a over x plus 1 plus b over x plus 2. We want that to be equal to just that 4x plus 7 over x plus 1, x plus 2. We know we're going to need common denominators, so we're going to multiply our a fraction by x plus 2 over x plus 2. And we're going to multiply our b fraction by x plus 1 over x plus 1. Now that our denominators are the same, we can ignore them. Now we've got ax plus 2a plus bx plus b, and that will be equal to 4x plus 7. So now we'll make our equations. Sorry about that. We'll make an equation out of our x stuff. So we have an ax, and we have a bx, so plus bx, and that will equal 4x over on the other side. Equal 4x on the other side. Then we'll have our equation with our plain old numbers. We've got that 2a plus 1b equals 7. So then we'll make our augmented matrix out of this. For our x equation, my coefficient on a is 1. My coefficient on b is 1. And that's equal to 4. In my plain old numbers, my coefficient on a is 2. My coefficient on b is 1. And that's equal to 7. So then we can go back to our matrix. We'll clear it out. We want a new matrix. It's 2 by 3. We have 1, 1, 4, 2, 1, 7. And we'll press enter. Reduced row echelon form of matrix A. So A is equal to 3 and B is equal to 1. So then we'll hop back to this. Now that we know that A is equal to 3 and B is equal to 1, we can go ahead and just use what we had over here. So remember, we still had that X out in front. We're going right here, I'm sorry. I'd already written it all out. A is 3, so I'll pop that on top of my x plus 1. B is 1, so I'll pop that on top of my x plus 2. And that guy right here is my answer. All right, see you guys a little bit later.